Good morning, Tehmina Khan is here in TKMaths is Fun. In today's video, we will continue studying surds and logarithmic function, which is chapter number 1 in Year 11 for the maths. Code is 4PM1, Pearson Edexcel. Now, we have already seen in the previous four videos these concepts: surds, rationalizing the denominator; logarithmic function, how to change it into index form; how to change index form into logarithmic function; solving log equations. And now this video is on a sketch of exponential and logarithmic function. There will be 2 videos on them because there are many graphs. So what strategy I have adopted to make the video short also? Initially, I have taken the images of the sketches to explain you the concept and help you to recognize the shape of their graphs. And afterwards, at the end, we will sketch few graphs. So let's start. There are 3 pointers basically in this topic. Number 1 is the functions of the type a power x, log x base b. For example, log x base 2 or maybe base 5, and a power x mean maybe 2 power x, 3 power x, 1 over 3 power x. So we will see all these type of sketches. And in the next video, most probably e power x and similar terms. So let's start. First of all, you need to get used to of the shapes. So now if you see here, this is the graph of e power x. E is also a constant, 2.71 something. So instead of e, if I have a number here, for example 2 power x, the shape will remain same. And similarly, if you see here, okay, before I show it to you, please understand this graph which is coming here, this side, it is not actually touching the x-axis. When we will sketch it, I will show it to you and I will explain it to you why. Keep the calculator in your hand. The graph is going toward the x-axis, but it never touches the x-axis. And that's why x-axis is called asymptote. So asymptote is that line toward which the graph approaches, but it never touches it. So this is the shape of exponential function. It could be this way or it could be this way. So I will explain it to you that also later, right? So right now you just have to remember one thing, the shape of the exponential graph. So it could be 2 power x, 3 power x, e power x. The shape will remain same. And you will always have horizontal asymptote. So you can write here, you can make a note here, horizontal asymptote when you have a function like this, e power x, 2 power x, horizontal asymptote. It's not always x-axis, it varies. I may have asymptote here and the graph is going like this, possibility, right? Depends on the equation. And then at the same time you will have y-intercept. So please remember, when you have exponential function, you have to focus on 2 things. Number 1 is y-intercept and number 2 is horizontal asymptote. It is must to show. Now let's see the sketch of log. So if you have ln x graph, or if you have log x base 2 graph, log x base 5 graph, all of them will have shape like this. Now you will notice here that for the log sketch, it passes through the x-axis. So you have to tell the x-intercept, must. So point number 1, you must know x-intercept. This you have to highlight to get full marks. And second thing is vertical asymptote. Vertical asymptote. How do we figure it out? That I will tell you, right, as the question will come. So at this point, you just have to remember 2 things in both the graph. In exponential graph, horizontal asymptote and curve passes through the y-axis, so y-intercept. And in logarithmic function, you will have a vertical asymptote, graph is trying to approach towards it, but it will never touch it, and you will have x-intercept. So let's move on. Look at this graph, y is equals to 2 power x. You can put the video on pause and use the points values in the calculator and see. If you put x1 in this sketch, y is equals to 2 power 1 in place of this. So when you put 1, you get value 2. If you put 2, you will get 4. So you can see that also here, right? Now what is happening on the negative values of x? I hope you can make connection here. So see here, this is something extremely important. When I have negative values, for example, -1, -2, -3. Now what is happening? See here, y is equals to 2 power -1. Y is equals to 2 power -2. Y is equals to 2 power -3. If I apply law of indices here, I can rewrite it like this. Agreed? 2 power 2 is what? 1 over 4. 2 power 3 is what? 1 over 8. So what is happening? The value in the denominator is increasing, but the constant in the numerator is same. So as you will increase the values in the denominator, the overall fraction value will become very small. And that is the reason, the y values, if I show you like this, just a second, very small values of y here, right? It is. So when you get very small values of y, for example at -2 and -4, so the graph will go closer and closer to the x-axis. So this is something very important you have to understand. So now let's see this graph. I have taken here y is equals to 3x yellow, y is equals to 2x blue, and y is equals to 1.5x purple. So if you notice here, because when you have to sketch on the same grid, 2 or 3 sketch, what you have to be careful about is the one which is in the lower side here is on the higher side here. So you can understand with calculator or with logic also, if it is equals to 3 power x, okay? I'm just trying to explain to you with the help of 2 or 3 sketch, and then we will move fast. So if I take y is equals to 3 power -4 and here 2 power -4, what is happening? Which denominator is bigger? Of course 3 power -4 denominator is bigger, and that's why this value will be small. So the graph which is on the higher side, on the right side with positive x values, will be on the lower side. So this is very important that you show the relation between them. The one which is on more steeper, high values will be on the lower side, on the left side. And these graphs, just let me erase this. Okay, so now, so all these graphs are passing through y equals to 1. Another very important thing which I have told you earlier. When you're sketching exponential graphs, they will intercept y-axis. And on y-axis, which value is 0? Yes, on y-axis, x value is 0. So in your function, if you put x 0, anything to the power 0 is 1. And that is the reason all 3 graphs, when you put x 0, answer is 1. They all are passing through 1. So if question asks you which point they will intersect at, you can say at y1, right? Makes sense? So, and the reason is only 3 power x is greater than 2 power x, and 2 power x is greater than 1.5 power x. So these are the things you can check through calculator also. Now, this is the one I have just discussed with you. So sometimes if it is written like this, what does it mean? 2 has power 1, right? So it is 1 over 2 power x. Because no matter what power is on 1, it remains 1. So we don't need to write e power x. Now, if I see this question is equivalent to this. So if I have to sketch this and I have to sketch this, what is the difference? Can you imagine? If you can make a picture in your mind, it will be something like this. And they both are meeting at y is equals to this. So whenever we have x positive, the power positive, the shape of the graph is from here. But when you have negative power minus x, you will have graph from here. They both will pass through y equals to 1. And they are reflection of each other in the line y-axis, right? Now let's see these. After 2 or 3 more graphs, then we will sketch here, right? So now if you see, it is y is equals to 2 power x and y is equals to log x base 2. So basically these are conversion of log form into index form, right? If I write here 3 power x, it means in logarithmic form it will be log 3 power x base 3. What is the connection between them on this sketch? On this sketch, the connection between them is they are reflection of each other in which line? This is log graph, and I have told you that log passes through the x-axis. Why it is so, I will explain the reason to you in a minute. Like I have explained to you the reason that why 2 power x will pass through 1 and why it will never touch x-axis. Similarly, I will explain to you for log in a minute. If you see, both of them are basically reflection of each other in the line y equals to x. So this is extremely important. When you have to sketch these two graphs, you always show the line y equals to x and show the reflection of each other. Now the next thing is y is equals to log x base 2, y is equals to log x base 5. If I change them into index form, it is basically 5 power x and it is 2 power x, right? So these graphs are reflection of each other in the line y equals to x. But if you have to draw these two on the same grid, which one will be has a bigger, more steeper line, I would say rather. In this case, of course, this is more steeper. 5 power f of x will go from here, 2 power x will go from here, and on the other side it will be on the upper side. Let's see in case of log what will happen. See here. Now let me explain it to you why it passes through the x-axis at 1. Let me explain to you here. We know, we have studied log already, that log of 1 is equals to 0, right? Now when we are sketching log graph, we know it will pass through the x-axis, right? This is the property I have already told you. It passes through the x-axis. So if log 1 is equals to 0, and we know on the x-axis y is 0, so to make y 0, this value 0, I must have x1. I'm repeating this concept. On the x-axis, y coordinate is 0. So from this equation, if I want to make y 0, then what x should be? It should be 1, right? That is the reason it passes through the 1 on the x-axis. But at the same time, what will be my asymptote? I know in the sketch of log, the asymptote will be your vertical line. And for that, how you will figure it out? Whatever is the function written here, you will say greater than 0, because log is defined for positive values only. So this helps you to know where you will draw your asymptote. It is x greater than 0. So x equals to 0 is which line? Y-axis. This line is called x equals to 0. So that's why your asymptote will be is equals to x is equals to 0, because the values should be on the right side. Correct? So now let's see and let's sketch this graph. So if you want to put the video on pause and try out these sketches, you can. Right? So I'm sketching it here now for you. First of all, y is equals to 5x. Now this is exponential function. I know it will intercept y-axis. So for the y-axis, I will put x equals to 0, because on the y-axis, x coordinate is 0. So if I see 5 power 0, it is 1. So this graph will pass through 1. And shape I already know, because if I increase the power of x like 2, 3, 4, the answer will be very big. So this side the graph will be like this, and this side it will go through towards the x-axis, but it will never touch it. And question is saying on the same set of x's I have to draw all these. So let me draw it little bigger here, because I have to draw all three of them on the same grid. So let's see here. Okay, so first one we have seen, it will pass through 1, and the shape of the graph will be something like this. So I can label it y is equals to 5 power x. Now y is equals to 7 power x. This one will also pass through 1 on the y-axis, because when I put x0, it will be 1. So now this will be more steeper, right? And it will be on the lower side here. Remember this thing. Let me use some other color so that there is no confusion. Okay, this is y is equals to 7 power x. Now what about the last one? Let me change green color. So this one is actually equals to 1 over 3 power x, which is equivalent to 3 power minus x. Now I told you when the power is negative, the sketch is from this side. So now it is 3 power x somewhere here, and you will just leave it here. It is going closer to it, so you can write y is equals to 1 over 3 power x, original form. So I hope you understood. You want to give name numbers here, 0, 1, 2, 3 on the x-axis, you can write it here, right? So this is how you will sketch this. Now let's see. On the same set of x's, sketch the graph of log x base 5 and log x base 7. Now in this case again, let's see here. First of all, of course you will use ruler to draw these lines. Now we know the log function intercepts the x-axis. I'm talking about this one first. If it will intercept the x-axis, then the y-coordinate will be 0. So if I put 0 here, then what should be the value of x? Log 1 always gives you 0 answer. So that's why you know it is 1. So it will pass through 1. And then log is defined for positive values only. So x is greater than 0. So your line x equals to 0 is your asymptote, which is in this case y-axis. The shape of the graph will be something like this. Okay, you can label it. So y is equals to log x base 5. Then it is log x base 7. So if it is log x base 7, what will happen? For your understanding, log 7, log x base 7 mean it is, if I change it into what it is called index form, it is representing y is equals to 7 power x, and this one is representing y is equals to 5 power x, right? So now 7, 1 will come here. Oops, just a minute. Okay. So now question is saying write down the coordinates where it will intercept the two graphs. So it will intercept at this point. Okay, now, so what about these graphs? On the same set of x's, sketch the graph of y is equals to 3x. So what you will do, you will simply reflect them in the line y equals to x. Remember, I told you the exponential curve and logarithmic graph are reflection of each other in the line y equals to x. So first of all, draw here the line y is equals to x, and you know my exponential graph will be from here passing through 1. So this graph, just like this reflection, it will pass like this, and this will be 1 for each one of them. So you can say y is equals to 3 power x, and this is y is equals to log x base 3. So I hope you understood these sketches and you will try yourself. In the next video, I will solve these type of questions and how to solve equation also with this. So thank you very much for watching the video. Please press like and subscribe button and share it with your friends.